Hey everyone. Was not expecting to be teaching this or in this format today, but yay, jury duty. Anyway, you do what you gotta do, eh? Yeah, and I already recorded this before, but for some reason it didn't save, so here we go again. Alright. Agenda. Okay, so we're going to do a little review. We're going to talk about Math Matters. Talk about a little symbolic representation, a little application. We're going to question into learning, and then we've got a review, preview, and that's right, homework. All right. So, review. We talked about the 5 E's. Really, the review is going to kind of be embedded throughout, so let's just dive in. All right. Ladies and gentlemen, boys and girls, make sure your seatbelt is securely fastened. Keep your arms and legs in the car at all times. It's about to get real. Alright, so a very famous person once said, "We use that which is not matter to contemplate or attempt to make sense of that which is or does matter." Who said that famous thing? That's a pretty good quote, isn't it? And I stand behind it. So, what the heck does that mean? Alright, so 4. And of course I have, things embedded in here for us to do if we're face-to-face or live or whatever, but we're not. So, here we go. Well, alright, so when my second son, Elijah, he turned 4 years old on his birthday, he came downstairs. I was making breakfast, and he was just a little thing. He was so cute. He stood back, and he looked at the table, and he goes, "Mom!" And I'm like, "What?" He said, "There are 4 chairs at the table." And I'm like, "You're right." He said, "I'm 4." And I'm like, "Oh my gosh, I can't believe it." Now, I don't know if that was just his way to remind me that it was his birthday, or even though I just sang to him and stuff like that, but I don't know what was going on. But 4 ended up being a pretty big year in his life. I mean, he learned how to read and ride a bike and two-wheeler and all kinds of stuff. But, yeah, 4 chairs. I'm 4. So what is this? What is it? What could it be? Alright, so let's think about this a little bit. Alright, so matter. I thought this was math. Yes, but math matters. So, listen up. Matter is the physical stuff in and around us. So, this pencil, solid matter. Solid. Okay? The unsweet tea within this cup, liquid. Matter. It takes the shape of its container. And then the spray that comes out of my stuff, that is gas. And it's matter. And it also takes the shape of its container. The room, your lungs, whatever. Our atmosphere. So those things are matter. It's the stuff, the tangible things around us. So it doesn't mean like everything is matter. I mean, look around me. I've got a lot of stuff in this office. Isn't it all matter? Yeah, all this stuff is. But what you think about it isn't. How you feel about taking a Zoom class today is not matter. I can be happy and excited, but the happiness and excited, those are emotions. And those are not matter. You cannot take happiness and put it into a jar. Now, I can put a cupcake into a jar, and a cupcake makes me happy, but the cupcake is the matter. The happiness is how you feel. So, it's, what you think, how you feel, like the color yellow. Yellow is, there may be a yellow car, but the color yellow is really theoretical. We just gave it a name. Okay? It helps to identify this car. And I would say that he's happy because he has a smile on his face. Is that Luigi? So he's a happy yellow car. But the matter part of it is, it's metal. It's solid. Okay. So that's what matter is and is not. Okay? Math is a figurative way to manipulate and understand the matter that is all around us. So I have 2 pencils. 1, 2. Okay? I can add. If I'm adding 2 pencils to 2 pencils, I put this symbol in the middle of it, and this represents adding, plus, okay, or subtracting. It's all symbolic of the matter that's around us. So sorry, I'm looking around like trying to figure out something to add and subtract, but I think you get it. So if I want to add, how many cars do I have? 1, wait, I'm backwards. 1 plus 1 equals 2. Okay, so this is a symbolic representation of this. But this could also represent these, or these, or anything. So it's just a figurative way. So you start off in kindergarten playing with counting bears, or blocks, or stickers, or whatever, okay, little erasers. And then you eventually graduate to being able to use the symbolic representation of those things. The problem is, once you figure out the symbolic representation, we begin to forget that they are symbolic representations. And we'll get into that in a little bit. So numbers are the figurative representation of the matter around us. So let's go back to that quote by that brilliant person. We use that which is not matter to contemplate or attempt to make sense of that which is matter. Thank you very much. I know you're clapping for me and you're like, oh my gosh, I have to watch that again. Mom, come here, watch this. It's amazing. I know. No off switch. Alright. So, and at this point, I would say, all right, so how are you feeling so far? So we can't do that because, like, we're visiting in this way. At least we're not getting behind in our studies, right? I know you're all so upset to not be in class right now. All right. So, all right, let's take a step back. So how does this apply to, how do the 5 E's apply to math? All right, so I understand that math matters, blah, blah, blah. But how does that all work? Well, let's take a step back in time, shall we? Do you remember this right here? Well, don't know what is happening. There we go. Okay. I engaged you into the content by asking you about candy bars. I mean, who doesn't like a good candy bar? I mean, I'm on like I'm trying to be not just a diet, but a lifestyle of eating super healthy and stuff, as you all know. Sorry about that. And, but I was having a really bad day the other day, and you know what I did? I got a Snickers bar. Not a gigantic one, a regular size, you know. But, man, that was good. It was so good. It was amazing. So anyway, if you can engage your kids, if you know your kids like, say, The Office. I'm engaging you by using The Office because I when I put this up here, I heard a lot of people go, oh yeah, and talking about candy bars. I mean, you got it. Especially money and candy, math. That's how you teach. You can teach everything in the kitchen because it all has to do with money and math. I mean, money and food. All right. Then I ask a question. So, how much does a candy bar cost today? And of course I made it silly, whatever. And then we had so right now you're still engaged, like, okay, like, no way, it was 4 cents for a candy bar back in 1900. Say, what? Okay. And then I gave you time to explore. So, if you had not been taught long division, like the steps in the process, you would have been like, all right, let's figure this out. I always had manipulatives at the front of my classroom. Tons of them. And I didn't just pull them out during specific times of the year. No, they were always available to my students. Because some people, you know, a certain manipulative makes more sense to them, and then, you know, others, another one. So you get what works for your students. Put it out there. They might want to use the manipulatives. Some may want to use the representation of the numbers. Some may want to draw pictures. Whatever. Think outside the box. Show your work. If you can think of one way, you're not done. It's like, what do I do when I'm done? Find another way. So you're engaging, and then you are explaining. All right, so how did you come up with your answer? What if the candy bars were 6 cents? Would it work the same? How do you know? What about your neighbor? What do you think? That's how it's. Did anybody else come up with a different answer? Well, whose is right? How do we know? Prove it. And they were like, I don't know, is this right? I'm like, I don't know, is it right? You tell me. And they're like, crap, I gotta think. Okay? So they're explaining, and you are giving them the opportunity to explain their thinking. And then we have the explore. And this is when the students are not explore, but elaborating. And they're coming up with their own questions, giving their questions to each other to solve. And then they get to play the part of the teacher and to determine, well, does their thinking make sense? Does their method make sense? I don't know. Eventually, the students will come around to seeing that, okay, even some of the questions are like, well, that took a lot of time. That's really cool. I love that tower that you built, or whatever. But that took a lot of time. Is there a simpler way to do that? Okay, so how does that way work? Okay, so you bring them around to the symbolic representations of the physical around them. And then some students will just automatically start with the symbolic, and then they can teach and show others. Eventually they'll all come around and they're critically thinking. You guys, in the schools, one of the main reasons why teacher candidates don't make it is because they don't know how to get students to think critically. It's not about the all-knowing teacher at the front of the class saying, you know, is this right, teacher? And you're like, yes, yes it is. Good job. Okay? No. You know the content so well, you don't have to teach it. Well, actually, you're teaching. You don't have to tell them. You can question, you can trick them into learning it so well that they can teach each other. All right. So when I say question into learning, these are some of the questions that I'm talking about. What have you come up with so far? What is that problem asking you to do? Where do you think you should start? What does this remind you of? How do you know? Would drawing a picture help? Can you explain that a different way? Is there another way? How did you find that answer? Why does that work? I mean, there are so many questions. And you might notice, if we ever get back into our classroom, that I have questions written around the room. Those questions aren't there for you. They're there for me. They're there to remind me. Well, I mean, they're there for you too, so you can see that I'm using them as an example. I'm trying to be an example for you. But it's very difficult to not say, yeah, you're right, good job. Or, no, that's wrong. Okay? So if a student asks a question, like, is this the right, am I doing it the right way? If I have these questions up around the room, I'll like glance by one on my way to that kid and I'll be like, oh yeah. I don't know, what do you think? Why? Why is it right? And then we're forcing them to think critically. Okay? Forcing them. We're giving them the opportunity that they would not have had we not asked. We're giving them time and opportunity to think critically. Because who cares if a certain program works, you know? Let me see here. Also, by asking them critical thinking questions, you're showing them that you care about how they think. And your interest in their thinking is a fantastic motivator. I mean, you are showing interest in them. You show interest in a student, they'll do anything for you because they believe that you care about them, whether you do or not. All right. Look at these two pictures. what do you see? Go ahead, take a minute. I'm readjusting. These are both taken in the early 1900s. This is a school, this is a classroom, and this is a factory. See any similarities? The answer should be yes. All right, so back in the day, my mom used to work in factories, all the women, and 7 generations of all women, no guys, crazy. They were all married in until I had my 4 boys. Anyway, broke that up, didn't I? The women in my family all worked in factories. I was the first to go from high school to college. But anyway, my mom, when I was younger, worked in an envelope making factory. And trust me, I mean, there's no thought. You're not allowed to think. You get in trouble almost if you think. Well, not almost. My mom got in trouble a lot because she's really smart. Yeah, she ended up going to college, and she went from working on an envelope machine to a heart-lung machine. How cool is that? Anyway, yeah, she's pretty cool. Well, anyway, so in a factory, it's just follow these steps. No thinking aloud. Do. This. And you do it repeatedly, over and over and over and over again. And that's what you do. You sit in rows or you stand in rows. You don't think. You don't talk. You don't talk to each other. There's no collaboration. That gets in the way of production. That's what these students were being prepared for. These were the jobs. These jobs have mainly been taken over by machines. This system will not work anymore for our society. Our society needs these students, our students, to be able to think critically, to understand the ins and outs, to be able to answer tough questions on their own without being told what or how to do it. Think about long division, like we talked about earlier. Follow these steps all the way through. Do it again. Think about the homework that you've had in math. Follow these steps all the way through. Do these steps perfectly. Do any of those numbers have any, do they actually represent anything? No. It doesn't matter. We don't want you thinking outside the box. We want you following these steps over. That's not today. That's not what we're doing today. And that's not what you should be doing in your classroom either. We should be questioning our students into learning. We are creating deeper thinkers. Thinkers that are deeper than what we are. That's our goal. My 4th graders used to teach me ways to multiply. I had no idea. And divide and all kinds of stuff. Alright. So, overview. And by the way, in your iceberg reflection, I'd like you to talk a little bit. I'd like to hear your thoughts about this portion of the video. Okay. Alright, so a little review, preview. Matter. What is and what isn't matter. Okay? Math matters. And being able to think critically about math and what math is and isn't matters. Numbers are symbolic representations of the matter that is around us. 5 E's, how does that fit into math? It doesn't matter what you're teaching. The numbers have to represent something, and there's more than one way to find the answer. And your students can find those ways. And if I just show them a different way, am I helping them to think critically? No, I'm just showing them another way. It doesn't matter if it's like this, or if it's like this, or whatever. It's still following steps in the process. And we need to allow them to find their own maps, their own steps, their own processes, by questioning our students into learning. All right, so a preview. Actually, hopefully, if we are together on Thursday, we're going to do some math magic. I'm going to blow your mind. But if we're not together because of ice and snow and jury duty, whatever, then I don't know. We might go ahead and do station teaching, but virtually. So again, this isn't ideal, but we do what we need to do when we're educators, and that's what I'm doing here. So, homework. Okay, so any Monty Python fans out there? So one of the Monty Python guys made this movie. It's called The Story of One, and it's the history of the number one. And it's absolutely brilliant, and it gets you thinking about numbers in a different way. And it gives you a more in-depth understanding of what numbers are, where they came from, why they are, and it's kind of funny. So the video is kind of grainy because it's old, but I think it's great. So watch the movie, answer the questions, and hopefully I'll see you in one way or another on Thursday.